Have you ever dreamed of traveling through time, hopping into a machine, dialing in a date, and witnessing history firsthand, or getting a sneak peek into the future? It's a fascinating idea that's captured our imaginations for centuries. But is it just science fiction, or could time travel actually be possible? Let's dive in. First, let's talk about what science says. According to Albert Einstein's theory of relativity, time is not constant. It's relative and can be stretched or compressed. This is known as time dilation. Basically, the faster you move through space, the slower you move through time. This has actually been proven. Astronauts on the International Space Station age just a tiny bit slower than we do here on Earth because they re-traveling at incredible speeds. So, in a way, they are time travelers, even if it's only by a fraction of a second. This means that traveling to the future is, theoretically, possible. If we could build a spaceship that travels close to the speed of light, we could journey into space for what feels like a few years to us, but when we return to Earth, centuries or even millennia could have passed. We would have effectively jumped into the future. The technology for this is way beyond our current capabilities, but the laws of physics don't forbid it. But what about traveling to the past? This is where things get really tricky. Traveling backward in time opens up a whole can of worms, famously known as boo-boos. The most famous one is the grandfather paradox. Imagine you travel back in time and prevent your grandparents from meeting. If they never meet, one of your parents is never born, which means you are never born. But if you were never born, how could you have gone back in time to stop them from meeting in the first place? It's a mind-bending loop that seems to defy logic. Some physicists have proposed solutions to these paradoxes. One idea is the multiverse theory, which suggests that every time you make a decision that could change the past, you create a new parallel universe. So, if you went back and stopped your grandparents from meeting, you'd simply create a new timeline where you don't exist, but your original timeline would remain untouched. You wouldn't just vanish. You'd be a visitor from another reality. Another idea is the Novikov self-consistency principle. This principle basically says that you can't change the past because it's already happened. Any action you take in the past was always part of history. So, if you went back to save someone from an accident, you might find that your actions are what caused the accident in the first place. The universe, in this view, has a way of correcting itself to avoid paradoxes. You can't change history because you are a part of history. So, where does this leave us? Traveling to the future seems plausible, at least according to our current understanding of physics, even if it's a one-way trip. As for the past, it's a much bigger question mark. The paradoxes involved present huge theoretical hurdles. While some theories offer potential ways around them, like parallel universes, we have no way of proving them. But let's think about the implications for a moment. If we could travel through time, what would we do with that power? Would we go back to witness historical events like the building of the pyramids or a concert by Mozart? Or would we be tempted to correct past mistakes, either our own or humanity's? The ethical questions are just as complex as the scientific ones. Changing one small event could have massive, unpredictable ripple effects, a concept often called the butterfly effect. Right now, a working time machine remains firmly in the realm of science fiction. The energy requirements to warp space-time or travel near the speed of light are astronomical, far beyond anything we can currently generate. And the challenges of navigating paradoxes and potential timeline contamination are immense. However, science is always evolving. What seems impossible today might become reality tomorrow. The study of quantum mechanics, black holes, and wormholes continues to push the boundaries of what we know about space and time. A wormhole, for instance, is a theoretical shortcut through space-time, and some have speculated it could be used as a time machine. If we could stabilize a wormhole, one end could be kept stationary while the other is taken on a high-speed journey. Due to time dilation, the moving end would age slower, creating a time difference between the two ends. Stepping through one way would take you to the future, and the other way would take you to the past. But again, these are just fascinating theories for now. Creating and controlling a wormhole is a task of cosmic proportions. So, while we might not be booking our trips to the Jurassic period or the 25th century anytime soon, the quest to understand time itself continues. The dream of time travel forces us to ask deep questions about the nature of reality, causality, and our place in the universe. What do you think? If you had a time machine, where would you go and what would you do? Let me know in the comments below. It's a fun thought experiment, even if it stays just that, a thought. Thanks for watching, and if you enjoyed this journey through time, don't forget to like and subscribe for more deep dives into the mysteries of science. See you next time.